So we have to check for that. Now BP, drug dose and disease. Now let us see here. You got the things and you have got all the data, and then you have seen that the numbers are not, n values are different. um, so that's the reason why it is called unbalanced. Now when you do ANOVA, you get this output, and p value is less than 0.001. Null hypothesis is rejected. So disease and interaction of drug dose and disease is telling that p value is less than 0.05. And p Tucky, if you observe blood pressure in, so A versus B, A versus C, B versus C you got. So now if you observe, blood pressure in disease A is significantly lower than B, and because this mean difference, and blood pressure in disease A is significantly lower than C, and BP is significantly higher in B than C. Now post hoc comparison, drug dose versus disease, if you observe, BP in disease B is lower if drug dose 1 is given instead of 3, and BP in disease B is lower if drug dose 1 is given instead of 4. So how do you observe this? When you have to just go through this table, and p Tucky you have to observe p value less than 0.05. You get the figures, and then B, and you are observing B here, and you are observing B is lower if drug dose 1 is given. So you are observing that if 3 drug dose 1 if is given instead of 3. If 3 is not given, then this output will be, the mean difference will be like this. If here blood pressure in disease B is lower if drug dose 1 is given instead of 4. So this is what we observe. How do we observe? So what is the conclusion? Drug dose 1 and 4 lower the blood pressure in disease A. Drug dose 1 lower the blood pressure in disease B. So now let us go through Fabulous India data. Questions are different but methods are same. Only parametric and non-parametric we have to see. So when it is non-parametric, how do we find it is non-parametric? We will go through the data normality, and if we find that p-value is less than 0. Shapiro-Wilk p-value is less than 0.05, so it is not normal. So you have to take non-parametric Kruskal-Wallis test, and then when you do this, you get the figure like this, and you have to find out the outcome. So, and you have to click DSCF, and you find out this kind of output, right? So the explanation is given here. Now let us go ahead and find out another kind of a data. So this is related to the concrete. So average strengths are same for all brand, and average strength is different in at least one brand, main effect. And average strength for standard and reinforced concrete are same, and average strength for standard and reinforced concrete are different. So this is interaction effect, and this is main effect. Okay, so this is brand, this is concrete, this one is brand, this is concrete, and this is related to the interaction. So with Jamovi, when we do this, we have got the output like this, right? So this is about the data given. You can do the plot here. Strength comparisons you can do. Now let us see this ABC Motor Company. Now there are 8 plants given. Each plant has 133 employees and 105 machines, and there are 2 suppliers for these machines. So the reasons for drop in productivity, so there is a the company has a bit drop in the productivity. So the company believes that maximizing productivity would reduce overtime cost, and corrective measures have to be taken, uh, and find out the reasons for the decline in the productivity. Right, so there are different data given for this particular question here. Now, higher rejections requiring overhauling of machine, upgrading old age machines cost rupees 8 lakh, low employee engagement cost of training program rupees 1 lakh, and absenteeism and employee discipline issue cost of retrenchment and rehiring 2.5 lakh. Now if you observe this, this is the figure related to the machine data. In the machine data, the data given is related to the supplier, age of machine and rejection. And city wise the data is given: Nasik, Chennai, Baddi, then Sanand, Midnapur, Hubli, various places the data is given. Now here the data given related to the daily production, number of employees present, and output number of units and number of hours worked. So this is data provided and city wise. Now here employee engagement score is given place wise, and then the case. Now if you observe, these figures are already given, so in the form of vertical data. So this particular question is related to the engagement. So because if you observe in this question here, absenteeism and employee discipline issues, cost of retrenchment and rehiring is this, and low employee engagement, cost of training program 1 lakh. So first is engagement case. So when company is trying to understand what is the level of engagement, so they have so when we do this normality test, we found that p value is less than 0.01, which is not the which is not normal. So when we are doing one way ANOVA, because we have taken the figure from this location and score, and we have grouped with location, and this is the dependent variable. So now because if you see the descriptive, so we find out that the figures given engagement related, you have got the figures given here. Now when we solve it, that we found that it is not normally distributed, so we do non-parametric ANOVA, right? And when we do this non-parametric ANOVA, we do it this way. We got Kruskal-Wallis p values less than 0.01, so null hypothesis is rejected, and this is showing the association between the variables. And if you observe the p values here, so interpretation of p-values of DSC F pairwise comparison, p-value is less than 0.05, then mean of group 1 is significantly different than group 2, and then we have to look at Welch value, which is less than 0, then mean of then we have to look at W. If W is less than 0, then mean of group 1 is higher than group 2. If W is greater than 0, then mean of group 1 is lower than group 2. So we have to observe this. Like for example, let's say P value is less than 0.05. So let us find out Baddi and Midnapur. So it indicates that this particular figure, average score in Baddi is significantly different than Midnapur. Also, since W is less than 0, we conclude that average score at Baddi is significantly higher than Midnapur. Okay. So this is how we have to interpret the data. And so this is how this particular figure is done. Now let us go to the next question. It is related to the machine. Now location is given, age is given of the machine, and rejection. So this data is from ABC machine data. So the second question is from the same data. So we are taking age and we are also taking rejection, that is percent rejection. So we are taking we are comparing location and rejection, right? So now let us see how it proceeds. Again, it is not normal, so we will take again non-parametric test. So when we'll take this non-parametric test, we are also seeing that here the association is 516, and then p value is less than 0.001. so mean rejection rates are different between different locations. And again, if you observe this p value less than 0.001, mean rejection rate at Mohali is significantly lower than Nasik. And again you will observe. Okay, so this is how you have to understand the data. And let's say, for example, the question is asked related to correlation. So you will perform correlation and you will find out that machine rate and rejection, machine age and rejection rate, what is the correlation. So you found that it is a bit low. So 0.32, actually we take, normally in research we take 0.5 above as good correlation, but moderate correlation lies between 0.3 to 0.7, and greater than 0.7 is high, and 0 to 0.3 is low. So it has negative correlation, and p value is less than 0.05, right? So this is what's Hubli, Sanand and Nasik have higher rejection rates than other locations. So we can find out from here. Same thing we have to do for location and number of employees present or absent. So we'll take one ANOVA. We see that this is non-parametric. So we'll do Kruskal-Wallis and we will take the data here and we will check less than 0.01 and we'll find out the figure.